Okay. I think we are going now. So my name is Stephanie Thanen. I am presenting today about the CCR5 Delta 32 genetic polymorphism and HIV-1 infection. This is a meta-analysis done by these three authors down here. And what they did is they pulled together a bunch of studies to come to this conclusion. So what this paper is about, it talks about a few things, kind of gives a background. So the CCR5 is a chemokine receptor that's expressed in several immune cells that are involved in inflammatory responses. This study in particular includes 24 case control studies, and they had 4,786 HIV-1 positive infection patients and 6,283 controlled patients. And then it showed that they did a stratified analysis by ethnicity, and they showed that there was significant association detected in the Caucasian ethnicity, that they were a carrier for the Delta 32 genotype. So didn't necessarily have it, but were a carrier for it. So starting off, HIV is the world's major infectious killer. It's estimated that about 36.7 million people were living with HIV in 2016 and still remains one of the biggest public health challenges. The CCR5 Delta 32 in particular is a 32 base pair deletion of the CCR5 gene coding region. So it's missing that region. It was initially discovered and gained great interest due to the relation with HIV-1 infection, and originally discovered due to the lack of homozygosity with preventing HIV-1 infection. So rather than being heterozygous and a carrier for it, it showed that people who are homozygous, recessive, it's a recessive trait, and had this 32 base pair deletion, seemed to not contract HIV after exposure. Though all of the researches are conflicting and inconclusive, still needs a ton of research on it. But this meta-analysis, this paper evaluates the possible role that this base pair deletion has with preventing HIV-1. So the selection criteria, kind of what they went through in order to choose the papers for their studies, they had to evaluate the relation between the CCR5 Delta 32 and HIV-1. So that had to be the focus of the paper. The case control studies had to be on human beings. They had to have sufficient data to evaluate the odds ratio and have a 95% credible interval. And the genotype distribution and controls must be that P is less than 0.001. So the P is the principle stating that genetic variation in a population will remain constant from one generation to the next in the absence of disturbing factors. So in biology, we kind of learned the p squared plus 2pq plus q squared equals 1. So the value of p has to be less than 0.001, which means there's a 0.1% genotype difference. 0.1% chance that the genotype differences are due to chance. And that's kind of back to the whole chi-square thing that we learned in genetics. So the results of this, 24 researchers were eligible for this study, and it showed a significant relation between the polymorphism and reduced risk of infection in homozygotes, and also showed significant relation between polymorphism and the increased risk of infection in heterozygotes. So this table shows the main characteristics of the studies that were included in the meta-analysis. They go back from 97 all the way up until 2018 is the most recent one. They're all from different countries. Most of the ethnicities are Caucasian. Sample sizes differ. It's kind of off there, but the sample sizes here, they all differ as far as size. And then this is, it's out of the way. This is the HWE, which is the Hardy-Weinberg equilibrium, which I will get to explaining in a little bit. But the Hardy-Weinberg equilibrium is the p-value. So this is the p-value here. In this one, this is the meta-analysis estimates. Hold on just a second. So this is just what they estimated for their studies. This down here is also the p-values. Here is the association between the heterozygous carriers and HIV-1 infection. So this is the odds ratio with a 95% credible interval, which if you had statistics, it's the credible interval is the same as the confidence interval that we learned in statistics. So it has to be in the 95% in order to be eligible for this study. And so this kind of shows here what's going on. We want the odds ratio to be low. I will get to all the results of that in just a second, but this table kind of shows what they found. And this is the association between the homozygous for the CCR5 delta 32 polymorphism and the HIV-1 infection. So this odds ratio, they're a lot lower than the heterozygous, which is good. So in discussion, kind of what they found is that AIDS remains one of the biggest health challenges of the world, and HIV is a precursor to AIDS. Chemokines and receptors are critical for immune response in the HIV-1 infection. And so this research shows that there's a significant relation between the CCR5 delta 32 polymorphism and HIV-1 infection in the total population. What they found is that heterozygotes, there was an increased risk of infection with an odds ratio of 1.16. So the odds ratio is a measure of association between exposure and outcome. So if it's equal to 1, then exposure does not affect the odds. If it's over 1, exposure with increased odds. So you have an increased risk of infection with exposure. And if it's less than 1, you have a decreased odds of infection after exposure. So we see here with heterozygotes, it's over 1, which means there's an increased risk of infection after exposure. It had a 95% credibility interval of 1.02 to 1.32. And it had a p-value of 0.024. So that means that there are other factors involved. In homozygotes, there was a decreased risk of infection with an odds ratio of 0.25. So that's significantly less than 1, which means your odds of infection after exposure are significantly decreased. It had a 95% credibility interval of 0.09 to 0.68. And then the p-value was 0.006, which is very, very close to the 0.001 that they wanted. So this just shows that there's a significant relation between polymorphism and the HIV-1 infection susceptibility in Caucasian subjects. And in my paper that I did, it showed that the reason that it was in Caucasian subject was due to the plagues in the Middle Ages that led to this mutation. So it was in England, Europe, over there, where it was primarily Caucasian people. So we see the increase due to that. That's just a theory. It doesn't mean that that's necessarily why, but that's definitely a theory that they have. This also had several limitations, which could influence the outcome as well. Only English and Chinese language-based studies were selected. This can lead to selection bias. Number as well as sample size was very limited, and the influences of other components such as age, gender, and lifestyle were not analyzed. So while this shows a lot, there's still a lot of factors that need to be brought in, which is why they say, there's still a lot that needs to be learned about this. But it's a step. So in conclusion, the findings indicated that the CCR5 delta 32 homozygous genotype confer possible protection against HIV-1 infection, especially in exposed uninfected populations. The results should definitely be studied large scale for more accurate representation, and there's so many other variables that contribute, it would be kind of hard to say exactly. These are my questions. So what is CCR5 involved in? Immune response, hormone control, or glucose regulation? How many case studies were involved? What is the CCR5 delta 32? And then what chemokines and receptors do for the immune response? Are they critical or non-critical? And then which genotype conferred possible protection? And that is it. I'm going to stop sharing here and then stop.